To most people, a yurt just looks like a round tent, a fabric cover, wooden poles, maybe a stove in the middle. Something simple, something temporary, something that looks easy because it does not seem very serious. But that impression is misleading. A real Mongolian yurt, also called agar, is an extremely refined survival structure. It can be fully assembled in about 30 minutes by an experienced family. It can handle brutal steppe winds that would flatten most modern tents. And it can stay warm in winters that drop far below minus 40 degrees Fahrenheit. That kind of performance does not happen by accident. It is the result of thousands of years of trial and error by nomadic herders who depended on their homes to survive. On the Mongolian steppe, there are no trees for shelter and very few natural windbreaks. Weather can change fast. Livestock has to move constantly to new pasture. A home that takes hours or days to build is a serious problem. The yurt solves this with design. Its round shape pushes wind around it instead of fighting it. Its flexible wooden frame bends without breaking. And its thick felt covering traps heat while still letting moisture escape. Like the igloo, the yurt looks simple because it works so well, but simple does not mean basic. Movies and documentaries often make it seem like every Mongolian person lives in a yurt all the time. Rows of white round homes stretching endlessly across the steppe, smoke rising gently from every roof hole, a lifestyle frozen in time. That image is about as accurate as saying everyone in Texas lives on a ranch. In reality, yurts are not permanent houses. They are seasonal homes designed for movement. Traditionally, Mongolian herding families relocate several times a year, following grazing cycles for their animals. A yurt is built, lived in, taken down, and rebuilt again and again, sometimes dozens of times over a single lifetime. This constant relocation is exactly why the yurt looks the way it does. Speed matters. Portability matters. Durability matters even more. A structure that only works once is useless on the steppe. A structure that cannot survive repeated assembly and disassembly quickly becomes firewood. Even today, many Mongolian families split their time between modern buildings and traditional yurts. Apartments and houses are common in cities. Yurts dominate rural life, especially during herding seasons. The yurt is not a symbol of poverty or backwardness. It is a specialized tool used when conditions demand it. And that specialization explains why it has changed so little over thousands of years. Every unnecessary part was removed long ago. Every useful feature stayed. When you see a yurt standing alone on the open steppe, you're not looking at a relic of the past. You're looking at a structure optimized for movement, weather, and survival. Before a single wooden piece is unpacked, before any ropes are untied, Mongolian builders focus on one thing first: the site. Just like an igloo depends on the right snow, a yurt depends on the right ground. The surface must be flat and firm. Ground that is too soft will shift under weight. Ground that slopes even slightly can throw off the balance of the entire structure. Experienced builders can judge this quickly. They look for tightly packed soil and short grass. They avoid areas with animal burrows, drainage paths, or signs of seasonal flooding. Wind is the next concern. On the open steppe, there are few obstacles to slow it down. Instead of trying to block the wind completely, builders position the yurt so it handles wind more efficiently. Whenever possible, they choose spots near gentle rises in the land that help reduce direct exposure. Orientation also plays an important role. Traditionally, the door of a yurt faces south. This placement limits exposure to colder northern winds and allows sunlight to enter throughout the day. A poorly oriented yurt can feel colder, darker, and harder to heat. It can also create problems with airflow once a fire is burning inside. By the time the site is chosen, much of the success of the build is already decided. A good location makes assembly faster and living easier. A bad location turns even a well-built yurt into constant work. Once the site is chosen, the next concern is materials. At first glance, a yurt does not look like a high-performance structure. Wood, felt, rope, nothing about it seems especially advanced or technical, but every material in a traditional yurt was chosen through generations of trial and failure. The insulation comes from a felt made of sheep's wool. This is not woven fabric. It is wool that has been soaked, compressed, and worked until the fibers lock tightly together. That process creates a dense mat filled with tiny pockets of trapped air. Air is the real insulator. The felt holds that air in place while still allowing moisture to slowly pass through. This balance is critical. Without breathability, warm air inside the yurt would condense on cold surfaces. That moisture would freeze, drip, and slowly weaken both the structure and the comfort of the interior. The wooden framework is just as carefully chosen. The lattice walls and roof poles are made from lightweight, flexible wood. They are not rigid beams meant to resist force at all costs. They are designed to bend slightly under pressure. When strong winds hit a yurt, the structure does not fight back. It flexes and spreads the load across the entire frame. That flexibility prevents cracks, snapped poles, and sudden failure. Tension is what brings everything together. Ropes wrapped around the outside of the yurt compress the walls inward. At the same time, the roof poles push down and outward against the walls. These opposing forces lock the structure into a stable shape. Remove the tension and the yurt collapses. Apply it correctly, and the structure becomes stronger than the sum of its parts. This is also why yurts can be assembled so quickly. There are no nails, no screws, no rigid joints that demand perfect alignment. Instead, the materials work together naturally. Under tension, the felt insulates better. The wood distributes force more evenly, and the entire structure becomes a durable, weather-resistant home built almost entirely from balance and pressure. When it comes to building a yurt, the tool list is surprisingly short. That is not because Mongolian builders lack technology, but because the structure was designed so the materials do most of the work. Traditionally, a yurt can be assembled with little more than rope, strength, and experience. Most wooden components are prepared in advance. The lattice walls fold and unfold by hand. The roof poles are shaped to fit into the crown without cutting or adjustment. Felt coverings are rolled, unrolled, and tied into place. There is no on-site construction in the modern sense. No sawing, no drilling, no constant measuring as the build progresses. At most, a simple mallet might be used to help seat joints, and a knife may be carried for cutting rope or trimming felt if needed. This simplicity is intentional. On the step, tools get lost, break, or freeze. A home that depends on specialized equipment becomes unreliable. By designing the yurt to rely on tension and repetition rather than precision tools, builders ensured it could be raised almost anywhere, even in strong wind or freezing temperatures. The lack of tools also speeds up construction. There is nothing to set up or calibrate. Each person knows their role. Each movement is familiar. Once the materials are laid out, the build becomes a practice sequence rather than a technical process. In yurt construction, tools are useful. They're just never the starting point. With the site chosen and the materials ready, the first real step of construction begins on the ground. This moment matters more than it looks. Just like an igloo, a yurt depends entirely on getting the foundation right. If the base is wrong, every step that follows becomes harder, slower, and less stable. The process starts with laying out the lattice wall, known as the kanal. The folded sections are placed end to end and slowly expanded outward. As they open, the wall naturally forms a circle. This shape is not decorative, it is structural. A circle distributes force evenly, which is essential for handling wind and roof weight on the open step. Getting the circle right is critical. If it is too wide, the roof poles will sit at the wrong angle. If it is too tight, the roof crown will not seat properly later on. Experienced builders adjust the wall by feel, pulling or relaxing the lattice until the spacing is even all the way around. No measuring tape is needed. Years of repetition make the correct diameter obvious. Once the circle is set, the door frame is installed. This is the only rigid rectangular part of the structure, and it must be aligned carefully. The lattice walls are tied securely to it, locking the circle into position and preventing it from shifting during the rest of the build. At this stage, the yurt is still fragile. Without roof poles or tension bands, the walls can collapse if pushed too hard. That is why builders move deliberately. Every tie is checked, every connection is tightened. By the time the circle is complete, the yurt already exists in outline. The shape, the size, and the balance of the structure have all been decided. From here on, the build moves upward, but everything depends on this moment on the ground. With the circle locked in place, the yurt finally starts to look like a structure instead of a collection of parts. This is the stage where the build shifts from preparation to construction and where experience begins to show. The lattice wall is slowly pulled upward and adjusted to an even height all the way around. Each section is checked by hand. If one area rises higher than the rest, it will affect the roof later. Builders correct these small differences immediately, long before they turn into larger problems. As the wall rises, tension bands are wrapped around the outside. These bands are critical. They hold the lattice in its expanded position and prevent it from collapsing inward. Without them, the wall has no strength of its own. With them, it becomes a flexible but stable ring capable of supporting the roof. This is also where teamwork matters. One person holds the wall steady, while another tightens the rope. Others move around the circle, adjusting spacing and making sure the lattice opens evenly. The movements are smooth and practiced. There is very little talking because everyone already knows what comes next. At this point, the yurt is still light and open. Wind can move through it freely. That is intentional. A closed structure too early would catch gusts and become harder to control. By keeping the walls open, builders maintain stability while preparing for the roof. Mistakes at this stage are subtle but serious. Uneven wall height leads to uneven roof pressure. Loose tension bands allow shifting later. These problems are much harder to fix once the roof poles are in place. By the time the walls are fully raised and secured, the yurt has gained its first real strength. It can stand on its own. The structure is no longer fragile. It is ready to carry weight. At this stage, the yurt begins to reveal why its design has survived for thousands of years. What looks simple from the outside is actually a carefully balanced system of forces working together. Tension, compression, and wind load are not problems to be fought. They are built directly into how the structure works. The lattice wall handles compression. As the roof poles are added later, weight pushes down and outward. The circular wall absorbs that pressure evenly, spreading it around the entire perimeter instead of concentrating it in weak points. This is why the wall must be a true circle. Any uneven section becomes a stress point under load. Tension does the rest of the work. The rope bands wrapped around the yurt act like a belt. They squeeze the walls inward while the roof poles push outward. These opposing forces lock the structure together. The tighter the system becomes, the stronger it gets. Unlike rigid buildings, adding pressure does not weaken the yurt. It stabilizes it. Wind load is where this design truly shines. On the open steppe, wind does not hit gently. Gusts slam into structures from all directions. Flat walls catch that force and fail. Corners concentrate stress and break. A yurt has neither. Its round shape allows wind to flow around it instead of stopping abruptly. The force is redirected along the curve of the walls and released on the other side. At the same time, the flexible wooden frame bends slightly under pressure. This movement absorbs energy that would otherwise snap rigid components. The roof also plays a critical role. Its shallow dome shape pushes downward force into the walls instead of straight to the ground. This prevents uplift, one of the most dangerous effects of strong wind. The more the wind presses down, the more tightly the structure holds itself together. This balance explains why yurts rarely collapse suddenly. Failure happens slowly and visibly. Ropes loosen, walls shift, roof poles slip. Builders notice these signs long before disaster. In a properly built yurt, every force has a place to go. Nothing is trapped, nothing is wasted. Tension strengthens. Compression stabilizes. Wind becomes just another load the structure knows how to handle. Speed is one of the most impressive features of a yurt. It is also the reason many first-time builders run into trouble. Trying to move too quickly without understanding the structure almost always leads to mistakes that slow everything down later. One of the most common errors is uneven wall spacing. When the lattice is not expanded evenly, the circle becomes distorted. This may not be obvious at first, but it causes problems as soon as the roof poles are added. Poles will sit at different angles, creating uneven pressure and forcing constant adjustments. Another frequent mistake is improper tension. Beginners often leave the tension bands too loose, thinking they can tighten them later. By the time the roof is in place, those bands are carrying most of the load. Tightening them at that point is difficult and risky. Poor site choice also shows up quickly. Even a slight slope can cause the wall height to vary around the circle. Builders then try to compensate by forcing parts of the structure into place. This only creates more stress in the frame. Some first-time builders rush the door frame installation. Because it is the only rigid component, any misalignment here spreads through the entire structure. A crooked door leads to shifting walls and roof poles that never quite settle correctly. Another tempting shortcut is skipping checks as the build progresses. Experienced builders constantly pause to look, adjust, and retighten. Beginners often keep moving, hoping problems will fix themselves. They rarely do. Most of these mistakes share the same cause: confusing speed with rushing. A fast yurt build comes from preparation and repetition, not from cutting steps. When built correctly, a yurt almost assembles itself. When built carelessly, every step becomes a struggle that costs far more time than it saves. Every yurt build leads toward a single critical step. This is the moment when separate parts stop behaving like individual pieces and begin working as one structure. Until now, the yurt has shape and potential, but it does not yet have true stability. That changes with the lifting of the tuno, the circular wooden crown that forms the top of the roof. This component determines the final height, balance, and strength of the entire yurt. Once it is in place, every other part must respond to it. The crown is raised carefully inside the circle of walls. One or two builders usually hold it at the correct height, while the rest of the team begins passing roof poles inward. Each pole slots into the crown and rests on the top of the lattice wall, creating a continuous connection between roof and wall. The order matters. Roof poles are added gradually and evenly around the circle. Placing too many on one side can pull the crown off center. Builders watch the alignment closely and make small corrections before moving on. This is not a step that can be rushed without consequences. As more poles are added, the structure begins to change. The walls stiffen. The tension bands engage more fully. The roof starts carrying its own weight. What was flexible moments ago becomes solid and predictable. This is the exact point where the yurt becomes self-supporting. The outward pressure of the roof poles is balanced by the inward pull of the tension bands. The walls compress slightly and lock into position. Every force now has a clear path through the structure. There is very little tolerance for error here. A crown set too high creates shallow roof angles and instability in wind. A crown set too low reduces interior space and affects airflow once a fire is burning. Builders adjust immediately if something feels wrong. Once the final roof pole is seated, the build pauses. The yurt stands on its own for the first time. Like the final block in an igloo, the tuntutu does not just finish the structure. It transforms it into a complete and stable home. With the structure locked in place, attention shifts from strength to livability. The interior of a yurt is not arranged randomly. Every element is shaped by airflow, heat movement, and daily use, all aimed at keeping the space functional in extreme conditions. Airflow is controlled primarily through the roof opening at the center of the tauno. This opening allows smoke from the stove to escape while fresh air enters through the door. Warm air rises and exits naturally, creating continuous circulation without mechanical systems. Height also plays an important role. The roof rises toward the center, creating usable standing space where it is needed most. Sleeping and storage areas are placed lower along the perimeter, where height matters less. This arrangement makes efficient use of the entire interior. The placement of objects follows a consistent logic. The stove sits near the center beneath the roof opening, allowing heat to spread evenly and smoke to rise directly upward. Bedding, tools, and supplies are arranged around the walls, where the felt provides insulation and support. When arranged correctly, the interior feels larger than it is. Air flows cleanly, heat spreads evenly, and the space functions smoothly without partitions or rigid divisions. The yurt becomes not just a shelter, but a balanced living environment shaped entirely by function. With the interior arranged, the final element that turns a yurt into a livable home is fire. Heat is not treated as something separate from the structure. It is designed to work with the materials, the airflow, and the shape of the yurt itself. The stove sits near the center, directly beneath the roof opening. This placement is deliberate. As the fire burns, warm air rises straight upward and exits through the tonneau. Smoke follows the same path, keeping the interior clear and breathable. At the same time, cooler air is drawn in through the door, feeding the fire and maintaining circulation. The felt insulation plays a critical role here. Thick layers of compressed wool trap heat inside the yurt while slowing heat loss through the walls. Unlike rigid insulation, felt remains flexible. It settles into place as the structure tightens, reducing gaps where cold air could enter. Heat spreads evenly because of the yurt's shape. The curved walls guide warm air around the interior instead of letting it collect in one place. This prevents hot spots near the stove and cold zones near the walls. Over time, the interior reaches a stable temperature that requires surprisingly little fuel to maintain. Moisture control is just as important as warmth. As people cook and breathe, humidity builds inside. The breathable felt allows that moisture to escape gradually. Without this, condensation would freeze on the walls and drip back down, making the interior colder and uncomfortable. The balance between fire, insulation, and airflow allows a yurt to stay warm even in severe winter conditions. Small, controlled fires are enough. There is no need for constant feeding or excessive fuel. When everything works together, the yurt becomes self-regulating. Heat is conserved, air stays clean, and the interior remains comfortable not because of technology, but because every element supports the others. In real life, yurts are not built as demonstrations. They are built because they are needed. On the Mongolian steppe, speed is not about convenience. It is about keeping up with the demands of animals, weather, and distance. Herding families move several times a year to find fresh pasture. Each move means dismantling a home, transporting it, and setting it up again in a new location. A structure that takes days to rebuild would make this way of life impossible. The yurt's design turns relocation into a routine task rather than a major event. Weather adds pressure to every move. Storms can form quickly, bringing strong winds or sudden cold. Being able to raise a secure shelter in under an hour can make the difference between a manageable night and a dangerous one. Speed here is a form of protection. Yurts also serve more than one purpose during these movements. They act as sleeping spaces, cooking areas, storage rooms, and gathering places. During long stays, families may add windbreaks or extra felt layers. During short stops, the same structure can be left lighter and faster to assemble. This flexibility is built into the system. Nothing about the yurt is fixed to a single location. Every part is meant to be reused, repaired, and moved again. Over time, families develop an efficient rhythm. Each person knows exactly where to stand and what to lift. That familiarity is why experienced builders can assemble a yurt so quickly. The speed does not come from rushing. It comes from repetition and design working together. On the steppe, a fast build is not a trick. It is a necessity that the yurt has been optimized to meet. A yurt is not meant to be built once and forgotten. It is designed to be maintained, adjusted, and reused over many years of constant movement. This ongoing care is not a weakness in the design. It is part of what allows the structure to remain reliable in extreme conditions. Ropes are regularly retightened as felt settles and stretches. Roof poles are checked for wear. Felt coverings are dried, aired out, and repaired when needed. These small acts of maintenance keep the yurt performing as intended and prevent small issues from becoming serious problems. Maintenance also improves performance over time. As felt compresses and conforms to the wooden frame, insulation becomes more effective. As tension is adjusted, the structure becomes more stable. Individual components can be repaired or replaced without dismantling the entire home, allowing the yurt to adapt season after season. This adaptability is one of the main reasons the yurt has endured for thousands of years. Families reuse the same materials repeatedly, and skills are passed down through practice rather than written instruction. Each rebuild strengthens both the structure and the knowledge behind it. The result is a home that continues to function even in the coldest months of the year. When winter temperatures plunge far below freezing, the yurt remains warm enough for daily life and sleep. Understanding how that warmth is maintained, especially overnight, leads directly to the next question. How do Mongols sleep in tents without freezing to death? Find out in this next video right here.